Hello friend, it's me. I heard you're stuck on a lake and I'm here to help. Okay, so first I made this fun little diagram that shows where you are on the lake. That's you and your little boat down there at the point 8060, and as you can see there's a buoy out there at the origin. So we want to know whether the water would be getting more or less deep if you were to start sailing towards the buoy. Luckily, we know that the depth of the water in this lake is described by the function f of xy equals 200 minus 0.02 x squared minus 0.001 y squared. So first we can figure out how deep the lake is at your current location. When we plug in the point 8060 to the depth function, we see that the output is negative 144, which means that the water is 144 meters deep at your current location. Notice that this value is negative, so a more negative value indicates deeper water, and a less negative value means the water is more shallow. So then we want to think about the path between you and the origin. We want to know how the depth of the water is changing along this path, and we can figure that out by computing the directional derivative of the depth function along this path. So to do this, we first have to find the partial derivatives of f with respect to both x and y, which we can see here are negative 0.05x and negative 0.003y squared respectively. So then we can use these to find the gradient, which is a vector whose components are the partial derivatives of the function. Then we can find the gradient at the point you're at, 8060, which is the vector negative 3.2, negative 0.18. Next, we will find the vector that connects your location at 8060 to the buoy at 00. This vector is negative 80, negative 60, but then we want to find the unit vector because we are only concerned with direction, not magnitude. So first we will find the magnitude of your direction vector, which we see is equal to 100. Then we divide each of the components of the vector by the magnitude to get the new unit vector of negative 0.8, negative 0.6. This vector now has a magnitude of 1. So then finally, we need the directional derivative formula, which is just the dot product of the gradient we found and the unit vector. We can plug in these two vectors like this, and we see that the dot product is 2.668, which is a positive value. So to interpret what this value means, let's recall that for our depth function, a more negative value indicates greater depth. So this directional derivative being positive means that the depth function is getting more positive or less negative in the direction of the buoy. Therefore, if you were to travel towards the buoy, the water will be getting less deep. So this is a safe path for you to take.